Greetings, this is Mary Jane Hayden, and today I'm going to tell you about the changes we made to FDM 210, which is the chapter on arterials and collectors. The first change I want to tell you about today has to do with our section for on-street parking, which is FDM 210.2.3. The language you see here on the screen is from the 2018 FDM. As you can see, there's quite a bit of information in this section, including some dimension requirements and also some information on how to treat bicycle facilities that are adjacent to parallel parking spaces. We realized that the dimensional requirements were already covered in the standard plans, and the bicycle information was probably better suited to be included in the bicycle facilities chapter, so we made some changes to the 2019 FDM. So let's take a look. Here's the updated language that's in the 2019 FDM. We didn't make any changes to the first two paragraphs here. But you'll notice that where we previously included language for dimensions and bicycle lanes has been removed. In its place, we simply refer to the standard plans for dimensional requirements and to FDM 223, which is our bicycle facilities chapter for bicycle accommodations on roads with on-street parking. Here's a quick look at the language that we placed in FDM 223. This is a new section within that chapter, and our webinar for Chapter 223 discusses this a little further, so be sure to watch that webinar too. FDM 210.4.6, which is our section on audible and vibratory treatments, or AVTs, was updated with a roadway design bulletin in March of 2018. This update built on the framework that was included in the 2018 FDM, and we also added language that was previously found in the usage criteria in the developmental standard plans instructions. So let's take a look. In 210.4.6, the major change was that we went from AVTs simply being a consideration to now being a requirement. Previously, the language said consideration for the use of audible and vibratory lane departure warnings is required for flush shoulder roadways with a posted speed of 50 miles per hour or greater. The updated language, which was included in the bulletin and is now in the 2019 FDM, says to provide AVTs, no longer a consideration. You'll also see that we've added more information in 210.4.6. Now we describe what AVTs are: cylindrical ground-in rumble strips, sinusoidal ground-in rumble strips, or profiled thermoplastic. We've also added some guidance on the expected increase in noise for each type of AVT to help the decision-making of which AVT to use on a project. Finally, we want you to use the same type of AVT throughout your project limits unless there's a clear change in condition. And on undivided roads, you need to use the same type of AVT on the center line as you use on the edge lines. Basically, we don't want you using a half mile of ground-in rumble strips and then switching to 500 feet of profiled thermo and then switching back to ground-in rumble strips. The subsections to FDM 210.4.6 were also updated with new language. Previously, FDM 210.4.6.1, our section on ground-in rumble strips, simply referred to the usage criteria in the developmental standard plans instructions for this particular developmental index. That usage criteria was brought into the FDM here in this section. Now you'll see a description of when to use the different type of ground-in rumble strips. Standard Plans Index 546-010 includes the details of each type. Let's take a quick look at each one. Type A is where the ground-in rumble strip is placed directly on top of the striping. This is only to be used on the outside paved shoulder when the paved width is between 1 and 5 feet. Also, Type A cannot be used for sinusoidal ground-in rumble strips or where there are residences within 650 feet. Type B ground-in rumble strips are placed next to the striping. They're offset from the stripe by 2 inches and can be used on outside paved shoulders that are 5 feet or wider and on inside paved shoulders that are 1 foot wide or more. Type C ground-in rumble strips are placed in between the buffer stripes in buffered bike lanes. These will probably be rarely used since we typically don't stripe paved shoulders with bicycle lane markings. However, if you happen to have a project where these markings exist, Type C ground-in rumble strips are available for that use. Type D are ground-in rumble strips that are placed on center lines. As you can see, they are placed on top of the skip lines and in between and slightly overlapping on the double yellow center lines. And just to note, the types are also noted with either the number 1 or the number 2. Number 1 indicates that it's a cylindrical ground-in rumble strip, and number 2 indicates a sinusoidal grinding. FDM 210.4.6.2, which is the section on profiled thermoplastic, was also updated. In the 2018 FDM, this section provided 4 bullets that described typical uses of profiled thermoplastic. In the 2019 FDM, we have strengthened this language to provide more direct instructions by saying, use profiled thermo in certain conditions. We also cleaned up the bullets a little and added a bullet about restriping projects where it has been determined by the district maintenance engineer that ground-in rumble strips would not be a cost-effective option. The next update I want to tell you about is in section 210.9 in table 210.9.1, which is our superelevation rate table for a maximum superelevation rate of 10%. We realized this past year that there was a note that we needed to add to this table. So back in the PPM, we had table 2.8.3 for maximum curvature of horizontal curves. This table was not carried forward into the FDM because it was repetitive information to what was already shown in the superelevation rates tables. As you can see here, the maximum degrees of curvature that were previously listed in table 2.8.3 are also shown in table 210.9.1 as the Dmax at the bottom of each column. So to avoid repeating information, we simply didn't place the maximum curvature table in the FDM. However, there was a note at the bottom of the table that did need to come over into the FDM. The note says that the maximum degree of curvature on interstates is 3 degrees, and it was inadvertently left out of the FDM. This is because table 2.8.3 of the PPM was the only place it was stated, and since that table was not moved into the FDM, the note was accidentally left out. So we've placed it here in FDM 210. And if you're wondering why an interstate note has been placed in the Arterials and Collectors chapter instead of in FDM 211, which is the Limited Access Facilities chapter, let me explain. If we look at FDM 211.8, which is the section on superelevation, then we see that this section refers us back to FDM 210. So this is one of the very rare instances where the Limited Access Facilities chapter refers back to FDM 210, the Arterials and Collectors chapter, for criteria. And that's why the note was added here. Another minor edit I want to bring to your attention is in table 210.9.3, which is the superelevation transition slope rate table. In the 2018 FDM, this table included 2 categories, high-speed roadways and low-speed roadways. This explanation dates back to the PPM as well, so let's look at the tables that this came from. In the PPM, our superelevation transition slope rates were presented in 2 separate tables. Table 2.9.3 was labeled Superelevation Transition Slope Rates for rural highways, urban freeways, and high-speed urban highways. Table 2.9.4 was called Superelevation Transition Slope Rates for urban highways and high-speed urban streets. When we combined these 2 tables into the single one in the FDM, which is shown here on the right side of the screen, we had to come up with titles for this information that would fit into our table. At that time, we chose high-speed roadways and low-speed roadways. Over the past year, we've realized that those titles are a little confusing and that the real intent of these 2 categories in table 210.9.3 is to convey the criteria for roadways using the 10% superelevation table and those using the 5% table. There may be an instance where you have a design speed that is low speed but must be designed for 10% maximum superelevation rate. An example of this would be a limited access ramp with a design speed of 30 miles per hour, which is an allowable design speed according to table 201.4.2 in FDM 201. And if we remember that FDM 211.8 tells us that limited access ramps must be designed for 10% maximum superelevation rate, then we can understand why table 210.9.3 needs to be labeled in this manner. The final update I want to tell you about today is just a clarification on our passing sight distance criteria. So if you've ever looked at FDOT's minimum passing sight distances in the PPM or the FDM, and then compared them to our values in the Manual on Uniform Traffic Studies, also called the MUTs, you know that they're quite different. The values in the MUTs are roughly half of those in the FDM. So to simply acknowledge and explain this discrepancy between the FDOT manuals, we added a statement below table 210.11.2, which is the minimum passing sight distance table in the FDM. The statement explains that minimum passing sight distances shown in the table are for geometric design and are different from the values found in the MUTs. The values shown in the MUTs are used as warrants for placing no passing zone pavement markings, and those values are based on traffic operating control needs, which are different assumptions from those for highway design. This concludes the webinar of the 2019 updates to FDM 210. Thank you for listening.